Hello everyone, this is Poorani. In the previous video, we saw few concepts from chapter 9, Light, Refraction and Refraction of class 10 NCERT book. This is a continuation of that video. Here we will see two important concepts for solving problems in this lesson. The first thing we will see here will be sign convention for reflection by spherical mirrors. Previously we saw what happens when light falls on a mirror, say if it is a convex mirror or a concave mirror. For both of it we saw the ray diagrams, we saw how the image is formed and all those things in the previous video. Here we will see the main concept we should know for solving problems in this chapter. These 5 points given here are the new Cartesian sign conventions. So we will go through these sign conventions for reflection by spherical mirrors. The point we should note here is when we draw a ray diagram, we have seen the pole and the principal axis. Say we will take a concave mirror for example and mark these points. Say this is we will call this P, the pole of the mirror, and this axis we all know as the principal axis. So these two are important points to be noted to know the sign convention. First thing is the pole P is taken as the origin. Yes, for any of the calculations, the distance we are taking is measured from this point P, which is the pole. Yes, the next thing we have to know is the principal axis. This line which is drawn here is taken as the x-axis of the coordinate system. Say this is the x-axis and all the measurements are made with this respect. So this P point, the pole, is the origin and the this axis, principal axis, is the x-axis. Keeping this in mind, we will go through the sign conventions. The first one says the object is always placed to the left of the mirror. So when you place it to the left of the mirror, say we place an object here. So when we place an object here, what happens? We have to measure the distance from this point. Say this P point or the pole which we have taken to be the origin. From this we have to measure the distance. So when we measure from the point P, this distance when it is placed in front of the mirror becomes negative as it is on the left side of the origin. So this implies that the light from the object falls on the mirror from the left hand side. Okay, all distances parallel to the principal axis are measured from the pole of the mirror. This is what we just saw. From this point we will measure the distance. All the distances measured to the right of the origin along the x-axis is taken as positive, while those measured to the left of the origin are taken to be negative. Meaning this from this point, if we are going to measure it in this direction, it will be taken as positive, and this direction we will take it as negative. So distances measured perpendicular to and above to the principal axis is taken as positive. So the height of the object placed here will be taken as positive. And if there is an image formed in the, say this is a inverted real image for example. So this distance will be measured perpendicular to and below the principal axis, so it is taken as negative. So these 5 points we should remember when we do the problems. So So this we will see as a picture here itself. So see, this is what we just saw. What is the first point? We said the object is always placed in front of the mirror. So if we have the mirror here, the object is placed here, which is in front of the mirror. You see this? And the next point, all distances parallel to the principal axis are measured from the pole. So this point P, this P is taken as the origin, and we measure the distance from this point P. And all distances measured to the right of the origin are taken as positive, and those distances measured to the left of the origin are taken as negative. So distances towards the right positive, distances towards left negative. So the next point is distances measured perpendicular to and above the principal axis are taken as positive. So this distance, height upwards, this is positive, and height downwards is taken as negative. So these 5 points we have to remember to do any of the problems in this chapter. So the next one we will see, this is again a very important formula which we will be using in the sums. The first one is the mirror formula. This mirror formula is going to relate three things: V, U and F. So now we will see what is V. What is our, so we will write down what is all this. So U is the distance of the object and V is the distance of the image, and F we already know is the focal length of the mirror. So when we say distance of the object, we just saw this object distance should be measured from the pole. So again the image distance is measured from the pole, and the focal length we know it is the distance between pole and the principal focus. So these three values are related by the mirror formula. This mirror formula is valid for all spherical mirrors for all position of the object. We have seen nearly 6 positions of the object for the concave mirror and 2 positions we saw for convex mirror. So in all these positions this formula is valid. So one thing we have to remember here is we have to use the new Cartesian sign convention. So when we are substituting for V, U and F, we have to keep in mind from where we are measuring. Is it to the right of the mirror or to the left of the mirror? If the object is if the object height, as we have seen, will be positive because it is placed above the principal axis. So if the image is real and it inverted, if the image is real and inverted, what happens? The image height will be measured below the axis. So meaning it will be in the negative y-axis. So these points we have to remember when we are solving the problem. So the next thing we have to know is the magnification. So as we all know, magnification is the size of the image with respect to the object. So that is what we have here. So the size of the image, or the height we can call it, the height of the image divided by the height of the object will give us the magnification. So this is also related to the distance of the object and distance of the image. So this is magnification is minus V by U, which is also equal to height of the image h dash by height of the object h. So again in this magnification formula we have to remember the new Cartesian sign convention. So when we have negative sign in magnification, say if your m is negative, it means that the image is real. Image is real. If you have magnification to be positive, then it implies that the image is virtual. So these 2 points we should be remembering when we are calculating the magnification. So with this we have understood, or we have tried to understand what is given for the sums to be solved. So these two formula are very, very important, and we have to keep in mind the Cartesian sign conventions. So with this we will move on to the problems. So yes, so this is the first problem, which is in page number 144, example 9.1. So as usual we will write down whatever is given in the sum. So we will go through the sum first. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meters, which means R is equal to 3 meters. Yes, this implies your focal length is equal to, is given by R by 2, which is 1.5 meters. So this is positive. Yes. So if a bus is located at 5 meter from this mirror, meaning your object, which is the bus, is located 5 meters from the mirror, the distance of the object is minus 5. Yes, minus 5 meters, because it is in front of the mirror. So when we use the new Cartesian sign convention, it is to the left of the pole. So you have a negative sign. Now what we should be finding? We should be finding first position of the object, position of the image V, nature and size of the image, for which we should be finding the h dash. Yes, the height or the size of the image we should be knowing. So we have found out f from R. So we will use the mirror formula. The mirror formula is 1 by V plus 1 by U is equal to 1 by f. So we have to find out V. So 1 by V is equal to 1 by f minus 1 by u. So we should not miss out the signs when we are substituting. So here f is positive, so 1.5 minus u is negative, so minus 5. Is that okay? So what do we have? 1 by 1.5 plus 1 by 5. So when we take the LCM, we will have 5 plus 1.5 by 7.5, which is equal to 6.5 by 7.5. This is 1 by V. So we have to find V, which is 7.5 by 6.5, which is 1.15 meters. So what do we see here? The image distance is positive. So when the image distance is positive, what do we understand is the image is formed behind the mirror. So it is a virtual image. So this is 1.15 meters behind the mirror, and a virtual image is formed. The image of the bus is formed in the mirror, which is behind the mirror. So now we have to find h dash. So m is equal to h dash by h, which is also equal to minus v by u. We have v and u. We have to find out h dash, or we have to find out m. So minus 1.15 by v is minus 5. So what do we have? We have a plus 0.23. So we already saw that when the magnification is positive, the image is virtual. So what is the nature of the image here? Virtual, erect, and diminished, because m is lesser than 1. Yes, diminished. So this is the first sum. Now we will move on to the second sum. This is the second example, 9.2, which is given in page number 144. So we will go through the sum. An object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. So what is all given in the problem? We have h, which is 4 centimeter. Then we have u, which is 25 centimeter. Then we have f. We have to remember that you should have a negative sign. Yes, and f is 15 centimeter, which is also negative because this is a concave mirror and the focus, principal focus f will be in front of the mirror. So these three things we have, and we have to find v and the nature and size, for which we should be finding h dash. So we will use the mirror formula, 1 by v plus 1 by u is equal to 1 by f. So we have to find out v. 1 by v is equal to 1 by f minus 1 by u, which is equal to 1 by minus 15 minus 1 by minus 25. So what do we have? We have minus we have the LCM to be 75. So what do we have here? We have minus 5 plus 3, so which is minus 2 by 75. So we have v to be 75 by 2 and with a minus sign. So this is minus 37.5. So what do we understand by this? We understand that the screen has to be placed, see, that's the question, screen has to be placed at a distance of 37.5 centimeters in front of the mirror. So we have a negative sign. So what's the next thing we have to find out? We have to find out the nature and size of the image. So this we will find out from the magnification, which is given by m is equal to h dash by h, it is also equal to minus b by u. So we have to find out h dash, which is minus u h by, minus v h by u. So we have to substitute the values for all these. So we will have h dash is equal to minus of minus 37.5 and h is 4. This is positive because it is lying above the axis. So and u is minus 25. So when we solve this, what do we get is h dash is equal to minus 6 centimeter. So your h is given to be 4 centimeter. So we see that the height of the image is greater than the height of the object, which means that the image is enlarged. So now what do we have? The nature of the image is real because we have a negative magnification, and we place a screen. So which means when you place a screen, it is always a real image. So real, inverted and enlarged. So we will go to the next question, which is in page number 145. We will go through this sum. Find the focal length of a convex mirror whose radius of curvature is 32 centimeters. This is a very, very simple sum. This could probably come for half mark or so, that's all. So what is given in the problem is radius of curvature r is equal to 32 centimeters. We have to find f. F is equal to r by 2. So 32 by 2, which is 16 centimeters. Such a simple sum. You just have to divide it by 2 and you get the answer. Yes. So we will go to the next problem. A concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? So we will write down what is given in the question. So it says 3 times magnified real image, meaning your m, magnification factor m is minus 3. Why is it minus? Because it is a real image. When the image is real, magnification is negative. That's what we have seen for the sign convention. So, and the object is placed at 10 centimeter in front of the mirror, meaning your u is equal to minus 10 centimeter. So what we have to find out, where is the image located? So we have to find out v from this. So how are these three related? M is equal to minus b by u. So minus 3 is equal to minus v by minus 10, which implies minus 3 into minus 10 is equal to minus v. So 30 is equal to minus v. Your v is equal to minus 30 centimeter. Yes. So the image is located at a distance of 30 centimeters in front of the image, and it is already given in the question that it is an enlarged image. So the image is real, inverted and enlarged. Yes. So in this video we have seen the first 4 sums in this lesson. With this we finish reflection part of this lesson. We will see refraction from the next video. Thanks for watching. Happy learning.